Hello everyone, welcome to VMS class. In this video, I am going to explain a web application for skin cancer detection. And we are going to build a complete full stack deep learning web application for multi-class skin disease classification. So using different kinds of frameworks such as PyTorch, FastAPI, React, Axios, and Anaconda software for creating the environment and for executing the project. And this application allows users to train the deep learning models. Okay, we are going to train three different types of deep learning models. One is ResNet 18, then ResNet 50, and VGG 16. We are going to train these three different models and we are going to evaluate these models. And we are going to have the training history. Even you can upload the skin images to evaluate the results, and you can predict the disease classes, and you can also find the confidence score with this web application. And coming to the final application architecture, so first we are going to have the React front end, so where we are going to display some of the details to select the model and learning rate and the training and testing split. Some of the details we are going to provide from the front end. And from the front end, it is going to connect with the Axios API request. And this is mainly used to connect the fast API backend. And then fast API backend, it's going to work in the backend and it is mainly helpful for training the deep learning models, etc. And also finally, we are going to get the prediction results in the front end. Okay, the front end never trains the models directly. So basically, the front end is just for viewing purpose. Only the front end can send the request to the server. Then backend is going to receive that request and call the deep learning functions. Okay, for that we are going to use the fast API. Okay, in this I am going to explain the step-by-step procedure how can we create a complete web application for the skin cancer detection. So for this, first you should have the Anaconda software in your computer. And I have installed the Anaconda in the D drive and the name is Anaconda 3. I have created a projects folder inside that. So let me show you here. I have a D drive. So inside that I have Anaconda 3 and inside this I have created a folder projects. Okay. Now if you don't have this projects folder, you can just create any name. Okay. So inside that I am going to create the new application here. So now inside this projects, I am going to create a folder or directory for the new project. Okay, I am opening the command from this. Here I am going to create mkdir. You can give the same name, okay, for reference purpose. Skin cancer app. Okay, skin cancer app. So here you can notice one of the folder directory is created and this directory is empty. Okay, so I have created a directory here. Then after you need to enter into this directory cd space skin cancer application. So now I am inside this skin cancer application. Now for developing this application, so you need to have three subdirectories. Okay. So one is a backend directory, another one is frontend directory, and the dataset directory. So for all the backend related data, I am going to store in the backend directory, and frontend related code or logic, everything I am going to store inside the front end, and dataset I am going to store inside the dataset directory. Okay, so for this, you can use either terminal or directly use your GUI for creating a new folder. I want to create three directories here: mkdir backend, mkdir backend. I am creating backend. I am creating front end folder and also dataset folder. Okay, now you can see this directory is now having three subdirectories: backend, frontend, and dataset. Okay, clear. So now you can see the structure is becoming something like this: backend, frontend, and dataset. All are empty folders only. Okay. So now you have to open the Anaconda prompt. I am closing regular command prompt. I am opening the Anaconda prompt here. Okay. So open this Anaconda prompt. So you can see the activated environment is base, and now you are inside the C drive users and Acer. So you can first navigate to D drive, CD space Anaconda 3, CD space projects. Okay, now I am inside projects, CD space skin cancer app. So now I am inside this skin cancer app. Okay, so now what you have to do, you need to first create a new environment. Okay, if you want, you can use the base environment also, but sometimes it is better to create a new environment, and I am going to install all the packages inside that environment. So this is the command which is to create the new environment. And what is the new environment here? Conda create new. This is my new environment, skin cancer app. So in this I am going to install Python 3.10 and -y, which is going to automatically accepts all the installations. So now inside this I am going to create a new environment. So this may take a little time. So it is going to install all the required things, including the Python 3.10 version. Now here the environment was created. So now you have to activate your Conda environment. So to activate this, you need to use a Conda activate the environment name skin cancer app. This is the environment which I have created. Okay. Now once you use this, here you can see that the new environment is activated. So remember one point here, whenever you are executing this project, so ensure that you should be in this environment. Okay. Otherwise, you may get some errors because the complete environment is going to have all the packages and setup, so setup configuration. Everything will be inside this environment only. So that is the reason. So ensure that this skin cancer app environment was activated. You can give any name, not a problem, but just ensure that this environment is activated. Okay, fine. So now there are three things. One is you need to set up the backend. Then after you need to set up the dataset. Then you need to set up the front end. Okay. First, I am going to set up the backend directory. Okay. So for this, you have to navigate to the backend. So in this case, I want to navigate cd space backend. So now I am inside the backend directory. Okay. Now you can create two directories to save our training models. Whenever the model is trained, the trained model is going to save inside this directory. And when you want to upload any image from the front end, at that time you have to save that image in the directory. So for time being, a temporary case, you are going to create this two directories here. Okay, mkdir. So the first directory is models underscore saved. Okay, another directory is uploads. Okay, now you can go to the backend directory here. Now I have created two subdirectories in this. One is models underscore save, and another one is uploads. And these directories will not do anything as of now. The only thing is in future, after the model is trained, the trained models will come and stored inside this directory. That's it. Okay. For example, I want to upload an image. That image temporarily will be stored inside this uploads folder. Okay. That is the reason I have created. So except that till now there is no use of these two directories. Okay. Clear. So this is the next step. Okay. You can see that models saved stores trained.pth models. Then it is going to store the images temporarily. Fine. So now I have to add three things inside this backend. So one is main.py, another one is ml service.py, another thing is a requirements text dot okay file. So if you add these three files, okay, you can add empty files also, but as of now I have three files with me. Okay, so now here go back. So I have three support files. One is main.py, second one is ml service.py, and requirements you can create now. Okay, go to the backend and paste here. Now I want to create one requirements file also. Okay, take a notepad, save this file as, go to Anaconda 3, then you can go to projects, skin cancer app, backend. Now here requirements.txt. Okay, requirement.txt file I have created. Fine. Say this. Now there are main.py, ml underscore service.py, and requirements dot text file is there. So now I want to install all the requirements. Okay, here you have to first open this requirement.txt file and paste this all okay content. Okay, which is the packages are required for execution of this project. So copy this and paste in the requirements .txt file. Okay, fast API I need, okay, for backend, and ubicon, okay, execution environment, Python multipart, pillow, and numpy. Okay, save this. Clear. Now we need to install the dependencies from this requirement.txt file. So now ensure that you are inside the backend. If you use directory, you see that requirements.txt file must be present inside that backend directory only. So I need to install all the dependencies from the requirement.txt file. So for this, you can use a pip install requirements.txt. Okay. Now all the, yeah, so you need to use pip install hyphen r. You need to install all these, okay, dependencies. Once you are using this requirement.txt file, from that only I am going to install all the dependencies. So, and what is the purpose here? Just you can see fast API for backend API framework. Ubicon is a fast API server. NumPy is for numerical operations, Pillow is for image processing, and Python multipart is for image upload handling. Okay, and even you can install this PyTorch and Torch Vision also from the requirements.txt. But sometimes what happens, there will be a conflict. So that's why I am going to install this PyTorch and Torch Vision separately. Okay, so let me complete this step. Yeah, this is completed. Now you need to install the PyTorch. Okay, you can install this in two ways. If you have NVIDIA GPU, you can use this command for PyTorch and Torch Vision. If you want to use your CPU, then you can use this command Conda install PyTorch Torch Vision CPU only -c PyTorch -y. Okay, so now click enter here. So now it is going to install the PyTorch Torch Vision for CPU purpose. So this also may take some time. Okay, please wait a moment till this step is completed. Okay, so meanwhile, okay, we can go to the step number 10. You need to have the data set. Okay, now I think you know that what is a data set and what is the format of a data set for a particular deep learning model. Okay, you no need to manually create these dataset folders. Okay, so here I am going to have one dataset. This is a skin disease classification. Okay, which is collected from the Kaggle website. Okay, you can go to this and click on the download. Okay, click on the download. So I have all here. You can again click on the download dataset, which is a zip file of 177 MB. Okay, here I have already downloaded this zip file. Okay, and I have extracted, and this is my data set here. Okay, if you download that, you can also get this kind of data set, which contains two directories, the training directory and validation, which we are going to use for testing. If you open the training, here we have 9 classes of diseases. You can open this one class, then you can find the images here. Okay, so ensure that for this project, the dataset structure should be training directory and testing directory. Inside the training directory, you should have all the classes, and each class contains the respective images of that class. Okay, so now what you have to do, you can try to, okay, copy this dataset, okay, copy this dataset and paste inside the dataset directory. So Anaconda 3, I am having projects folder, and inside this skin cancer app, I have created a data set here. Now inside the data set, you can paste this data set. Okay, so now the data set is ready. I have copied the data set. Okay, so data set preparation, this data set is already okay available with me. Now you can see the data set structure. This is the folder name, and this has training directory, and inside the training directory we have 9 classes, and each class is containing images, something like this. Okay, this is the structure. Okay, now let me see whether this previous step is completed. So we have installed the, okay, PyTorch and Torch Vision also. Fine. So now let's come to the execution process. Now we have three files. One is mlservice.py, another one is requirement.txt, another one is, so we have seen the main.py, right? So you can go to the backend. Okay, I have created three files. Requirement.txt, we have successfully completed. Main.py and mlservice.py. Okay, so let me open this Visual Studio. I am going to open this with a Visual Studio. Go to File, open the folder, D drive, Anaconda 3, Projects, Skin Cancer App. Select this. Now you can go to the backend and let me open the main.py. Okay, main.py. And you can also see the ml service.py. So now the mlservice.py contains all the information how we can load the data, what is the image processing methodology, data loader creation, model building, training. So everything we are going to have ML service. Okay, so all the things are present inside the ML service. And coming to the main.py, so this file creates the fast API backend server for training, prediction, and models. We are going to have this main.py. Now, coming to this ML service, you need to change the path. Okay, so here, once you get this, here you can change the path of this directory. Okay, so now this is the path which I have given. So what you have to do, you can copy this, okay, data sets, and till this you copy and paste here. Okay, so now this is the data set path. Okay, so rest of the thing is everything is same, no need to change any details. Now we are completed with the backend part. Let's check whether this backend server is perfectly running or not. So we have to navigate to the backend directory. Already I am inside the backend directory here. So you need to start the backend first. Okay, for this, what you can do, Python space -m uvcorn, okay, main colon app reload. So this is mainly useful for auto restarting the server. If any code is changed, by default or automatically the server will be restarted. Okay, now you can notice that the backend is going to start. It is going to show, we'll watch for changes in these directories. If any change is happening in this directory, it is going to automatically restart it. Now the application is started. If you want to start the backend alone, you can just click onto this. Okay, navigate to this link. Okay, so then you can see, you can find a message, skin cancer detection backend is running. If you want to see the docs, okay, or to test the backend APIs, what you can do, you can select docs here. Okay, extension docs here, so that it can open the Swagger GUI. Okay, you can see Swagger API documentation, you can see this. So this is mainly helpful for testing your backend APIs. Okay, so you can see what are the available models, and if you want to train a model, you can train it using the train. If you want to test it, you can test the model using test or predict. Okay, so now for example, this is my models. Okay, so if you want, you can just click on try it out and click on execute. Okay, so you can see what are the available models here. So here we have three models are available: ResNet 18, ResNet 50, and VGG 16. Okay, so this is the API here. Then if you want to train a model, okay, so go to the train and click on the try it out. Okay, click on the try it out. Here it is going to ask four, okay, parameters. What is the model name? For example, I can give ResNet 18. Okay, I am going to give two epochs. Training test split 0.80 I can give. Learning rate is 0.001. So then click on execute. Okay, so that you can see whether the backend is running or not. You can see here in the terminal, backend is started. Okay, I have given two epochs. Epoch 1 bar 2. So totally two epochs are there. Epoch 1 has already started. Okay, so like this, you can test this backend first. If the backend is properly working, then it is good to go and start the process of front end, okay, setup. Okay, so hope it is started. No need to wait much time. Okay, because everything is perfectly running here. Because it may take some time. It has to complete the two epochs for 22 batches. Okay, so what we can do, I can stop this process. Okay, I can stop this process. So now I want to set up the front end. Okay, so let's go back and set up the front end. So I am creating the front end using the React. Okay, using the React. So you have already seen some of the videos before how to create the React app. So the same process, we can go to the skin cancer app. Okay, let me open a new Anaconda prompt for front end. So ensure that you must activate the skin cancer app environment. So go to the D drive, cd space Anaconda 3, cd space projects, cd space skin cancer app. Now you are in the root directory. So for this, I have to create the activate the environment. Okay, let's check the name of this environment, skin cancer app. So Conda activate skin cancer app. Okay, now you can see that the skin cancer app environment was activated. Now, so I want to create the front end using VITE. So what you can do from this, okay, you can create a VITE, okay, npm create VITE at latest, okay, then space front end. Already we have created the front end directory. So it means that you are going to create one front end kind of project inside the front end directory. Okay, if you click enter, then it is going to ask, so which framework you want. You can scroll down, okay, and select the React, and it will ask the variant. You can scroll down, okay, and type or select the JavaScript here. Once it is installed with npm and start now, you can click yes. Okay, type Y there, automatically it is going to start the installation of all the dependencies with npm. And you can go and see this front end directory. Previously it is empty, right? Now you can see the some of the files are already coming over to the front end folder. So it is basically a front end dummy project is going to be created. Okay, if you want, just I will show you a dummy project also. So let me continue the next step. So we need to install a few more dependencies like npm install and npm axios. Yeah. So you can see that. Okay. After this, it is going to create one. Okay. Front end server. Okay. Now copy this and paste anywhere. Okay. Here. Yeah. You can see this front end server has started, and this is a dummy kind of project. Okay. Now I want to replace this front end, okay, logic which is present in the src app.jsx with my, okay, front end code or front end logic. Okay, that we will see after this. Okay, let's do Control C in the front end. Do you want to terminate? Yes, because I want to install few more things in the front end. So here you can install npm install. It is going to install all the dependencies which having default React and Vite packages from package.json. Then after, okay, we have to navigate to front end, right? cd space front end npm install. Yeah, packages are installed. Then you have to install npm install axios. So this is used to send a request from the React frontend to Fast API backend. So React frontend to Fast API backend, there is a connection. So that is going to happen with AXIOS. Okay. So now you can notice the front-end structure is something like this now. Okay. Most of the things are done. Now you notice that this is my front end code. That is a dummy project which is giving by the React, right? Now what we have to do, you have to replace our logic, okay, our front end. So for this, I have already this app.js file, okay. You can copy this app.jsx file and paste inside the front end src. Here you can replace app.jsx file. Okay, already app.jsx is there. Okay, now if you go and see, okay, and refresh this. Okay, okay, let me start the front end server again. Okay, npm space run space div to start the front end server. Now here server was started. Now you can go and refresh this front end. You can see that my front end logic is there. So this is the home page of our skin cancer detection. Okay, so whenever you are testing this from the front end, so try to check this backend. Okay, backend is running or not. So you try to verify it. If backend is stopped, then you cannot execute or test the front end logic, right? So now backend is also running. So here I have three things. One is you can train a model, you can predict the image, you can train the results. Okay, you can see the training results also. Okay, so now I am going to select a ResNet 18 here. I want two epochs. Training test spec is 0 0.8, learning rate is 0.001. You can click on the start training. So now you can see a message is coming. Training is started. Okay, you can see. Okay, let me open this backend again. Yeah, so backend is stopped actually. So you can restart the backend using this command python -m ubcorn main:app reload. Okay, so now Front end is also running, back end is also running. Okay, let's refresh this page. Now select these parameters: ResNet 18, epochs 2, training split 0.8 and 0.001. So then click on start training. Now you can notice that training is running. Okay. Check the backend terminal for live epoch logs. If you want to see some live updates, you can go and check in the backend. Here you can see some of the details like training images are 697, validation images are 181, data loaders created successfully, building model, which model you are using, ResNet 18, number of classes 9. Okay, so training has already started. Okay, so again, this training will take some time, so you have to wait it, okay, for some time. So if you are using the GPU, then maybe the training is very fast, but I am using only CPU for demonstration purpose. Also, the accuracy is depends upon the number of epochs also, okay, number of images also. The multiple things are there. Just I am going to show you how we can train and test a model. So after the training is completed, it is going to evaluate the model on the validation data. Once this validation is completed, again epoch 2 will be started. Then again, after the training is completed on epoch 2, then again validation will go. So we have just given two epochs here. We need to wait all the two epochs are completed for all the batches. Now the training is completed and the model ID was generated. This is the unique ID which we are generating, and the model is saved at model save. So as I told you in the beginning, so there is a folder we have created inside the backend model save. You can see the model which we have generated. Okay. And remember this model ID, I'm copying it. The training accuracy is 72%, validation accuracy is 65%, and final loss is 0.72. Okay, don't worry about the accuracy and loss because we have just trained for two epochs. Okay, so now you can predict an image, how it is working. Okay, so click on this predict image. So here you can use this model. Okay, you can give them ID of that model, then select the image which you want to predict. Select any image. So go to the Anaconda projects, any some random image you can take, skin cancer app, dataset. So select any one image from the validation, not from the training. Okay. So select any one of the image. Okay. And open it. So it will show you the selected image is this one. Then click on the predicted image. Okay. Now, once you click on the predict image, it is going to show you prediction result is, okay, the class name and what is the confidence of that. Okay. It is going to show you what is the prediction results of that particular image. Okay. So train a model which is used for training the model to predict the images. Okay. You can use this prediction tab, and training results, the previous training results are going to be stored here. Okay, so like this you can try the three different models. ResNet 50 is there, as well as VGC 16 is also there. So you can try to train different models with multiple epochs. Increase this epoch number also, which is going to provide better results. Okay, so this is a complete pipeline, so which is showing a training process and testing process of skin cancer image classification. So using the front end and back end connectivity. Okay. So I ensure that when you are executing the front end, the back end must be running. Okay. Also, another important point, when you are executing this, activate this environment because everything you have installed inside this okay, skin cancer app environment. Okay, if you want, you can give any name also, not a problem. Just you need to install everything in one environment and you have to activate that environment before executing the project. If you are interested in developing such kind of projects, so please enroll to our course that is given in the description. Thank you. I will see you in the next video.